we are going to derive the fundamental condition for the direction of spontaneous change of any process. From the second law, we know that the change in entropy is always positive and is related to the heat transfer divided by the temperature. Now, if the process is occurring at constant pressure, then enthalpy is the heat transferred at constant pressure, and this equation becomes ds is greater than dh by t. If you rearrange this inequality, you get a differential change in enthalpy minus the temperature multiplied by differential change in the entropy is a number less than 0. Now we define a new thermodynamic variable called the Gibbs free energy, which is the difference between the enthalpy and the product of the temperature and the entropy. A differential change in the Gibbs free energy can be written as dH minus TdS minus SdT. Now if the process is also occurring at constant temperature, then this term SdT falls to 0 because dt is 0, and the equation becomes dg equals dH minus TdS. Now if you combine equations 1 and equation 2, you get dg is less than equal to 0. So this is the condition for the direction of spontaneous change for any process that is occurring at constant temperature and constant pressure. The condition will change if the process occurs, for example, at constant temperature and constant volume. Now if the process is at equilibrium, if the system is at equilibrium, then there is no direction of spontaneous change, and the condition for equilibrium is that the differential change in the Gibbs free energy